To start this lesson, we are going to look at problems you did last year involving trigonometry and finding sides. So first off, I would definitely take the time to copy down each of these problems on a piece of paper before you start working at them. So you might want to pause the video. So when I read this problem, the first thing I see is that this triangle is a right triangle. So I'm going to draw a right triangle. It looks like angle F is the 90-degree angle. I'll put the D and the E over here. Angle D is 32 degrees. And side D, so I'm not sure if you learned this last year, but basically when we see side D, that's just the side across from angle D. So the 40 would go over here. Then it asked me to find F. So F is the side across from angle F. We use lowercase letters for sides, uppercase letters for angles. So once I get to here, if I have a right triangle, and only if I have a right triangle, I can use SOHCAHTOA to solve for parts of this triangle. So looking here, I have my angle. So this is the opposite side, and this is the hypotenuse. So when I'm choosing what to use in SOHCAHTOA, I would have to use sine because I have opposite and hypotenuse. So setting this up, I have the sine of 32 equals the opposite side, which is 40, over x. From there, we can cross multiply. We'll make this a fraction. We could also multiply by x on the same side, on both sides. So I get x sine 32 equals 40. And then to solve for x, I would divide by the sine of 32. If I type this in my calculator, making sure that I am in degree mode, I would end up with 72.5 to the nearest tenth for that side. So you can try that and make sure that works. Now, in the new problems we're going to be learning, we aren't going to be able to use SOHCAHTOA because we won't have right triangles. Now, there are two laws that actually come from SOHCAHTOA. Just like the quadratic formula comes from completing the square, we could go through a process to prove these. I'm going to put the proofs of these laws in the comments if you want to look at them, but for now we're just going to use them. So I'm going to change this problem, and we'll look at one where we can first use the law of sines. So here's our first example for law of sines. It says in triangle UVW, measure of angle U equals 33, measure of angle W equals 89, and U equals 380. Find W to the nearest hundredth. So the first step is always to draw the triangles. So I'm going to draw a triangle. Actually, I didn't like the way that one started. It doesn't really matter what your triangle looks like, just that you have a triangle there. So the angles don't have to be in proportion to what you see. I'm going to make this U, V, W. Angle U is 33. Angle W is 89. And just a side note, for some reason on Delta Math, instead of having this symbol, there's like a weird square in the front. And I think that that's just the program not rendering the font correctly. I'm not really sure. But this, when you see that on Delta Math, this little square means angle. So from there, U equals 380. Now, the law of sines says that in any triangle, not just right triangles, so this works for any possible triangle, a side over the sine of an angle equals any other side over the sine of the angle across from that side. So it's very important. You have to have pairs, so angles and sides across from each other. Remember, lowercase means side, uppercase means angle. And this, if you can set something up to solve with this, this will work for any triangle. It actually works always in place of SOHCAHTOA as well. And once you learn it, it's a little easier than SOHCAHTOA because you can use this formula without deciding if it's sine, cosine, or tangent for anything. So when I look at this, what I'm looking for is a known side angle pair. If I can circle two that I know, then I could plug them in the formula in one of the fractions, and then whatever other third piece of information I have, I can use to find something else. So here it asked me to find side W to the nearest hundredth, so I'm going to put a W over here. And this pair could go in the other fraction, and I can solve from there. So let's just set it up. We'll plug it in. So A over sine A in this case would be U over sine U. So 380 over the sine of 33 equals B over sine B would be W over the sine of angle W. So from here, once again, you can basically just cross multiply because we have two fractions equal to each other. So I get, and we always put the side first just to make sure you don't end up plugging this 380 into the sine. So I usually do side times the sine of the angle. And so here's the other side. We're just cross multiplying W times the sine of 33. So from there, I could type in the one side, but what I'm going to do next is just divide by sine 33. Type this in as a fraction just to make sure you type it in correctly. You should pause the video and type it in yourself, but if I typed this in on my calculator just to make sure you're doing things correctly, I would get that side W is 697.60. Okay, so when I look back over here, I wanted nearest hundredth, that's why I have this 0.60. So we're going to try another problem with law of sines. Basically, you're always looking for that pair you know, and then a pair you're looking for. So in this case, U is the pair I knew, and W is the pair I had the side I was looking for. So here's our next law of sines problem. Make sure that somewhere you have circled, written down the law of sines for when you do the problems, and also, once again, make sure you're copying down the problems so you can see them. I did the weird notation for the angles this time, you'll see, just so you can see what it'll look like on Delta Math. So I'm going to draw out my triangle. I should have a degree symbol there. So this one is X, Y, Z. I kind of always draw my triangles basically the same, but as I said, it doesn't really matter if they're in proportion, just that you can see the picture. So I have angle Y is 139, angle Z is 20. We'll put the X over here. And then I have side X with the lowercase is 940. My goal is to find side Z. So here, I don't see that pair that I know. But the goal is, law of sines, when you see law of cosines, you'll see law of sines is kind of the easier one. And I am able to create a pair because I have two angles I know. I can find the third angle using the fact that the angles of a triangle add up to 180 degrees. So I'm going to add up the two I know and then subtract from 180. And that will give me that this third angle is 21. So now I do have the pair I know. So I can use that for law of sines, and then I have the pair where I'm looking for one of those parts. So I'll write down the law of sines since you're just learning it. Law of sines says A over sine A equals B over sine B. And it would be true, it's also equal to C over sine C. We only need the one fraction to solve though. So looking here, my pair I know are the ones that go with X. So I have this side is 940 over the sine of 21, and just make sure it is important that the angle goes with the sine. You can't put the sine of 940 here. Okay, 940 is the side. So my other pair, I have Z I'm looking for, that's the side over the sine of 20. Okay, we're going to cross multiply. So these two go together and these two. So I get 940 times the sine of 20 equals Z times the sine of 21. I'm actually expecting an answer pretty close to 940, kind of similar because these angles are pretty close to each other. It's not going to be super, super close, but if it's pretty close, I won't be surprised. So from there, I'm going to divide by sine of 21. And if I type this in my calculator, I would get that side Z equals 897. One thing on Delta Math, they do give inches or feet or whatever. You don't have to type that in your answer. So this one, nearest whole number, would be my final answer. So here's our next example, and you will see with this information that I'm not going to be able to use the law of sines, and we'll be using our second law, which is the law of cosines. So in this triangle, I have EFG. I have that G is 127. I have side F is 50, and I have that side E is 62. I want to find side G. So you can always just put an X here. I'm putting G just to show that that's side G across from angle G. So if I look here, there's no way for me to get an angle side pair, basically because I only know one angle. So I can't subtract and find the other angles. Side G I do not know, so this is not a known pair between angle G and side G. So we're going to use something called the law of cosines. So the law of cosines, also coming from SOHCAHTOA, if we did a little proof for that, I'll put that also in the comments, says that a squared equals b squared plus c squared minus 2bc cosine of a. So this one kind of looks like Pythagorean theorem. The hypotenuse does not have to go in for a. The big thing in this formula you need to know is that whatever side you put here, you have to put the angle across from it here. So these two are a pair that have to be a side angle pair. So because in G, I usually won't know, or I will never know both of them. One of them is going to be something I'm solving for. So I'm always solving for either the A, the little a, or the big A that goes with cosine. So this is the one I'm working with. So I'm going to put G in for the A in a squared. And I'm going to put cosine of 127 over here. So it's always how I started out. You'll see with the way the formula is written that B and C are interchangeable. So I'm just going to put 50 squared plus 62 squared minus 2 times 50 times 62. So they can go in either spot. Let me just get that plus sign better. Now, the way we're using law of cosines in this lesson, basically, I can just type this whole thing in because it's all numbers. So pause the video and type that in. You're going to get a big number. We're going to have to take the square root. So this one ends up giving me 10,075.25 approximately. Just like anything else we've done in this course, we keep the whole decimal in our calculator. So from there, I'm going to take a square root of both sides. And I get, using that whole decimal, that G is to the nearest 100, 100.38. So we're going to try one more with law of cosines. So in this example, I have triangle ABC, where angle B is 80. I have that A is 850 and C is 250, and I'm trying to find side B. So I'm going to write down my law of cosines because I automatically see that I don't have that side angle pair that I know, so I can't use law of sines. Now, one thing I did purposely on this problem, I made it so I'm not going to actually plug in the sides for the letters that match them. My pair that I'm working with, where I know the angle and I'm finding the side, is the B's. So I'm actually going to put those in where the A's go, because the big point is the letters don't matter. You're pairing things up with like pairs. Okay, so I'm plugging those in for the A's, and I'm going to put the A and C values in for the B and C. So this gives me B squared and then cosine of 80 on this side. And then I have 250 squared plus 850 squared minus 2 times 250 times 850 in here. Sorry, that's a little bit hard to read. That's an 850. So I'm just plugging in these two have to go in for these two because that's the pair that I have. So from here, if I type in the right side of the equation, that's going to give me 711,199.52. And then when I take the square root, I'm going to get that side B equals 843.3. So that's law of sines and cosines. Make sure you have your laws copied like on your notes somewhere so you can see them nice and easily when you need to use them.